Okay. Hello, everybody. It is 4 o'clock local time, right on the dot. And I just want to welcome y'all all back to the session. This is our third and final one for Symposium 15. Before we get started, just a couple of reminders. You have 10 minutes for talk and 3 minutes per questions. If you go over the 10 minutes, it'll just cut into your question time. Once the 13 minutes is completely up, we will have to have you get off of stage and start switching to the next speaker in order to stay on schedule and to make sure everybody gets their fair amount of time. And additionally, I would like to remember to thank all of our Diamond sponsors and all of our sponsors in general for making this meeting possible with their contributions. So if we don't have any questions generally before we get started, I would like to introduce our first speaker, who if you've been here earlier, you have seen, Sanson Poon, if you'd like to come up to the stage. Oh, and that's a great slide.
Yes, it's an interesting first slide, but yeah, welcome everyone to this session again. And I know this is the final session of the day, so I'll go with something that is easy. So in this talk, there's no formula, no science is involved. It's just talk about to try to share the experience that we have while we're trying to bring AI into a museum, into an area that have a lot of traditional research is happening. How are we going to bring this new AI idea into the museum? So to start with these slides, I think it can be many of us is have you ever wondering what AI can do for you? Or have you ever have an experience that you have a lot of data, a lot of specimens, you don't know how to deal with it, but maybe AI is something that can help you to do it? Or have you ever tried when you do research, trying to go online and read a paper? People mention about this AI model can do 99% accuracy to the work that you have been doing in your entire life. So is it going to change your life? Or what does this paper means? Is it actually correct that is it actually getting 99%, and what does this 99% accuracy means? Or have you ever have some idea in research that you're trying to think, okay, maybe AI can work, but how can I start? I don't know much about AI. So we all wish there is a magician coming with a digital crystal ball and to try to solve everything for us. So how can we deal with this kind of problem is something that I want to share today in this presentation is using the Natural History Museum in London as an example. How are we going to establish a program which is called the NHM AI Lab to try to bring all these kind of AI ideas, AI questions, or AI potential applications together into traditional research and the collection? So the Natural History Museum, we have a very huge collection of specimens, more than 80 million specimens, and at the same time, it's a very huge research institution. We have more than 300 plus full-time researchers doing different type of life science, earth science, ecology research. So a lot of diversity that is in the museum. And the museum, different research team in the museum, they start having trying to think about what AI can do. And then they all have some people trying to apply some kind of AI work into their research. But at the museum, even within the same organization, within the same building, different teams, they don't talk to each other. So we find out that a lot of teams, they are actually working on very similar problems, but they never know the other team is also doing something similar. So in this kind of environment, we think that it is good that we try to establish a more systematic platform to try to bring everyone together within the museum and let them talk to each other and even talk to some AI experts or the AI team within the museum, and then see if there is anything else we can do, or is there anything that we can bring our current work to the next level. So we established this NHM AI Lab as a program to try to bring everyone within the museum together. So the NHM AI Lab, together with the Natural History Museum, so we're not trying to use AI to replace any human. We are not trying to create a lot of AI application out of nowhere and then suddenly tell people, okay, let's use this AI model. We collaborate with researchers, with scientists, with curators in the museum, and then we listen to them, and then we try to come up with some idea and try to bring some things together. So I think this kind of model can apply to a lot of different organizations, maybe including the organization that you're in yourself as well. How can you bring people together within the same organization if you only have, let's say, a small team of AI experts within your organization? So this is a model that we trying to do, that we are testing. So we have been running this AI lab for more than a year now. So in here, so I just want to share some of our experience and how can we actually accelerate the way of collaboration within organization. So a quick summary about the NHM AI Lab is we provide a lot of different help in-house, provide a lot of in-house expertise for the curators, for the researcher within the museum. So we do personalized AI consultation with all of our colleagues. So if you work in the NHM, you have a problem that is AI related, maybe you read a paper, you don't understand it, maybe you have an idea about AI you want to apply to your work, they will just come to talk to us. And then we also start a lot of proof of concept, like this POC research project together with them as well, that at the end become another independent program within the museum. And then we also try to use AI to build research tool for our curators and researchers as well. And one very important thing that I feel experience that I can share is this AI coffee, which I put a quote in there, is actually, I think that is the most efficient way of try to bring everything together. So don't underestimate the power of free coffee and biscuits if you want to bring researchers together. I can say that more than 50% of the new collaboration that we have under this NHM AI Lab, the first conversation is come in this kind of AI coffee session. So maybe if you really don't know how to start bringing people together, give them some free coffee and biscuits. So yeah, at the moment after running this AI Lab for a year, we have more than 20 new projects that can possibly be delivered. Because before we have this AI Lab program, the researcher won't have a chance to make all of this kind of idea possible. So again, the NHM AI Lab is not trying to do project just within a small group of AI experts. We are working together with collection and with scientists to enable a lot of collaboration using AI. So next, I'm going to go through some of the project that we have under this AI Lab program. Of course, I'm not going to go into details about this because it would take me another whole day to talk about this. But for example, one of the highlight project that we have is the nanofossil project that I talked about this earlier today. And then also we use some kind of similar technique that we collect by the HMS Challenger, which is a boat that go around the world 150 years ago, collecting a lot of data. And now the data is just stay in a jar in the museum, no one can use it because there's a huge amount of them. But with AI, there is some possible research that can be done if we start applying AI to this kind of data set. And then we also study a lot of things about diatoms using AI. And we also study a lot of teeth, for example, how do we classify different dinosaur teeth, also the shark teeth that my colleague Arianna is working on. Also, we not only do science research, we also help the museum collection as well, which, like for example, in here, we try to do like condition survey to different like sliders specimen. And instead of like computer vision, we also do a lot of things about, let's say, the public health. For example, here, like the mammal disease outbreak prediction. We also try to do like dog and cat classification, but not use an image, but their like infrared spectrum of their hair. We're also trying to build like communities of like bird. So a lot of things are happening, not only like image, but also like a lot of different type of data, and including like LLM as well. So these three projects, I think, again, my colleague Arianna is going to talk about it later in this session. So I will leave this to her. And also we are working on like data that is like not even collecting within the Earth. Like we also work on data that collecting from the moon. And then we also work on things that is related to the robotic arms that, again, my colleague Arianna mentioned it like yesterday in the features talk. And like, so many things are happening like within the team, and then we try to do a lot of things to bring people together. And the result and the outcome of this kind of project is going to help the data standard really well, because all of this project here is going to end up with a data set, a new data set that is up to a standard that AI model can train on that. Like other different like AI use case can use this data set as well. And then we also will have like software code that come out from this kind of research as well. So just by trying to set up a collaboration platform for your organization, it already can enable a lot of research happening. And the result of like this kind of research, many of them also lead to different, like let's say, publication, like grants, award, and also some of them even have like commercial value. So one of the project here, because of the non-disclosure agreement that I've signed, I can't really say which one, but actually a third-party market research company suggested that there is like between like 10, 20 millions of potential revenue that is for the museum to gain. So just by setting up a systematic platform for collaboration within your museum and do things up to a good standard, a good practice under AI, can enable a lot of potential and opportunity that every one of us may be able to have a chance to achieve it. So AI is not a magical black box. We all struggle in our research question. We all struggle about like what kind of use case we can come up with. But always think about maybe it is worth talking to someone who know about AI, who know about statistics, or if your organization don't have this kind of like resources, feel free to come to talk to us, the NHM AI Lab as well. All right, so I think I will stop here. Thank you very much.
We have time for one question. If anybody has one.
Thank you. Very interesting. I just have one simple question. How many people work in this AI lab in your institution?
Very good question. So all the projects that I list out in here, you will only see two names that keep repeating, which is including myself, Sanson, Poon, and my colleague, Arianna. So only two of us, and then we are working on this 20 plus projects. I didn't list out all of them, but like, yeah, a lot of them, yes.
Awesome. Well, thank you so much. Let's give another big
Thank you.
hand. And our next speaker is virtual. It is Michael Torma, and he will be presenting on, excuse me, evaluating Language models for specimen label OCR, a comparative study using published GBIF data.
All right, everyone. Welcome to our presentation about the comparison of large language models for herbarium sheet digitization. My name is Michal Torma, and I did this presentation with collaboration with Rukaya and Johaadien. We are both from GBIF Norway at University of Oslo Natural History Museum. Now, we already experimented with LLMs for a few years now, and we have this pipeline for digitizing herbarium specimen sheets, where we use images of these sheets to get OCR. Then we use LLM to standardize this chaotic OCR text into standardized JSON, where we get Darwin code terms directly. So the plan for this little presentation was to check out how that works within different models that are available now. We decided on a subset. I will talk about it later. So the first step, the way we digitize the specimen, is that we take this image that has already been created by institution, and we run it through Google Vision API and extract the chaotic text that you can see here. Then in the next step, we take the OCR and pass it with a special prompt to LLM. Here we can see it's a shortened version of the OCR. And here are the example results. Here we can see what Llama 3.1 8B did, GPT-4o, or Claude Sonnet. You can see it extracted the actual terms pretty well and reasonably, that we can then put in a table and just publish or have somebody look at it. So for the testing data, we decided to get roughly 1,200 records of herbarium sheets that are already digitized and published on GBIF. And this was chosen because we wanted to have a large spread over the different languages which can be used. And we also wanted to have a spread of different techniques people take pictures of herbarium sheets in their institutions. So it turned out to be roughly 150 random records per dataset, and here is the list of datasets. I'm saying roughly because as we were running the analysis, we were losing some records because some didn't have a valid image at the end, even though we didn't know, and things like that. So we had to sort of trim them to end up with these numbers. This is a system prompt that we are using. You are an adept herbarium digitization system. You see, it's always nice to massage the ego of any LLM you are working with. You're working on an OCR text extracted from images of scanned herbarium specimen. First, you correct any obvious OCR errors, and then you extract only the following Darwin code terms. And there is a list of terms with the shortened definitions of the terms. So at the end, we ask it to, if you can identify information for a specific term, and or the term is blank, you skip the term in the response. Your response is in minified JSON. Then we have some way of telling it what is important. So it should only respond in JSON and nothing else. And it should only use the data and do not create fictional data to try to mitigate the hallucination problem. So the models that we decided to use were Llama 3.1 8B, which is the only open source model from out of these, or as open source as the big models get. And that one we run locally, and others like GPT-4o and all of these from GPT family, and Claude 3.5 Sonnet we ran through the API. So the results are basically all summarized in this one slightly more complicated table, but bear with us. This is the comparison of the human transcribed Darwin code terms that are already in GBIF with the term that was extracted from LLM using our prompt and the OCR. And it's compared using fuzzy library, which is fuzzy matching of the two terms. So 0 is no connection at all, 100 is full-on connection. Here we can see that it's comparison to the humans. So models are ordered in a way that the lowest one has the highest mean similarity to what model came up with. And here you can see that arguably most important terms like scientific name, year, country code, decimal, latitude and longitude are pretty good. So what, when, and where seem to be covered fairly well. And you can see that GPT-4o, which is the latest and the most expensive model to run, is on the top, but the others are not that far behind. So it's questionable whether it makes sense to use GPT-4o for these kind of tasks. GPT-4 Turbo, which is even older than GPT-4o Mini, is actually much better than GPT-4o Mini. Claude Sonnet is surprisingly low on the list here, but that also might be that we were developing our prompt on GPT, and maybe there are different techniques and that might be better suited for use with Claude. And unsurprisingly, the worst is Llama 3.1, but do not be swayed, because even though it's last, it's still not to be shamed on. It's 78 compared to 73 on Llama 3.1. I think those are pretty nice results for the model that you can run on one GPU pretty much anywhere, and you can let it run nonstop without paying money, except for electricity. So these are the general results and consensus about this. Some of the terms we found out are really hard to compare with fuzzy match. So in reality, often these data identify and verbatim identification are actually higher or more similar. It's just that humans also, we can't consider the human transcription to be the real truth. Now here we can see the Llama, which is the worst model, compared with other models in itself. So here, where it compared, it's actually really good with comparison to GPT-4o. It's most like that one. The issue with Llama 3.1 we had during running is that it often doesn't produce the valid JSON at the end. For this, we changed the approach a little and asked it 3 times, and if it didn't create the valid JSON after 3 tries, we just decided that this one data point is fail. So we gave it a little bit more inference compute, but the results are pretty good. And if we gave it even more inference time compute, we can expect the results to get even better. So conclusions. Llama 3.18b is surprisingly capable model for its small size, and we think that it's very important for us to look in the future into these open models more, and maybe start using them on a general tedious tasks of maybe rechecking the herbarium specimens that are already published and annotating them in some way. And that way we can improve the data quality of GBIF. Another conclusion is that some fields are hard to compare with fuzzy match because they are either numerical field or the logic of the fuzzy match just doesn't match all the terms the same way. So maybe we should develop some more sophisticated ways of comparing which Darwin code definition of a herbarium specimen is actually better than the other. The last conclusion that we came up with is that it would be worth testing bigger Llama models like 70B and 405B, but due to the lack of resources that we had during preparation for this presentation, we didn't manage to do that, but we are planning to do it in the future anyway. So those would be interesting to see. And this kind of analysis, I think, makes sense to repeat year after year so that we know what we can use and what makes sense using. All right, thank you for your attention. And I would like to thank our sponsors GBIF Norway and HMNUIO for resources that we could use to run this analysis. We appreciate your attention and engagement. And if you have any questions, feel free to contact us at helpdesk@gbif.no or through any other mean you can find. And here is a link to GitHub repository for the all underlying data for the analysis. Thank you and enjoy the conference.
So we do have a couple of minutes for questions if anybody has one, and I'll be monitoring the online chat. And if you do have any, feel free to come up to the microphones.
And I want, let me think. I found every LN has its ability to deal with the project. I think, is there any chance to let each LN to be an ensemble model and to voting which answer they want to get the better results? Is there any chance of that?
Yep. Hi, can you hear me?
Yep, we can hear you.
Yeah, great. So of course there is a possibility for fine-tuning and making this much better. The question is the resources and how much money there is. If you consider the whole GBIF and data published, which already has a digitized specimen, if we consider the human transcription to be correct, or at least like they are mostly correct, so for training that should be good enough data. So there is a possibility for fine-tuning and making it even better over time. I hope that answered your question.
Cool. We have time for about one more question. Does anybody have anything else? Cool. Well, thank you so much, Michael, for your presentation and for answering those questions. Let's give another big hand for him. Okay, cool. So our next presenter is also virtual, but will be available for questions. We have a talk on automating information retrieval from biodiversity literature using large language models, a case study from Vamsi, Krishna, Kommineni.
Hello, good afternoon. I am Vamsi, a PhD candidate at the University of Vienna, Germany. Today I am going to speak about how large language models can aid in extracting information from biodiversity literature. So when I say biodiversity literature, it comprises of many diverse topics like species, taxonomy, policies, conversation on ecosystems, and many more, as shown in this word cloud, which only summarizes some topics of biodiversity. On the other hand, large language models are trained on huge amount of data, which makes them to understand and generate human-like text, and they can also perform various tasks like text generation, classification, annotation, and information retrieval, and many more. So our main aim is to leverage the capabilities of large language models and RAG approach, which means the retrieval augmented generation, to analyze and retrieve the information from biodiversity literature. So this is our complete automated information retrieval pipeline. So in which the left side part represents the simple RAG approach, where the publication is divided into subdocuments and their embeddings will be stored in a vector store. So whenever the LLM is prompted with a query, then it will get the relevant chunks from the vector store based on the similarity of the query. And then they both query and their respective relevant chunks are provided as an input to the LLM. So then the LLM will frame the human-like response. So where we process that response and compare it with our previously available manual retrieved answers. If you are wondering where the manually retrieved answers came from, then the next slide will answer those. So in our previous work, which we presented in the last year TEDx conference, where we used keywords from previous research to query Google Scholar, which resulted in more than 8,000 publications. After data processing, we only used 61 publications to manually extract deep learning methodological information from the publications. So the information we extracted is like data, code, hyperparameters, and so on, as shown here. So for this current pipeline, we have converted all those variables like dataset, code, and so on from our previous work into the queries as shown here. For example, dataset is converted to, is the dataset used in a deep learning pipeline publicly available with persistent identifiers? And the remaining variables also converted to queries in a similar manner. So this is a prompt template we used. So we simply prompted, use the provided pieces of context to answer the query. If you don't know the answer, just say that you don't know and don't try to make up an answer. And here the query is a placeholder. Every time the query is different based on the queries we framed in the previous slide. So let's see example outputs for 3 different publications for the same query. For example, here we asked the query like, what are the hyperparameters used to train the deep learning model? Here we also provided examples like number of epochs and so on. So now let's look at the answer 1 from random publication. So here it explains how many epochs the model is trained on, and what is the filter size, and what is the number of layers are there, and what are the nodes, and then the dropout value used during model training. And now let's look at the answer 2. Here it indicates there is no information about the hyperparameters in the given context. And now let's look at answer 3. So this is also from random publication. So here it clearly explains which hyperparameters are used in different stages of the pipeline. So for example, look at the learning rate. Here it states the learning rate used for stages 1 and 2 was 0.001, and while stage 3 used a learning rate of 0.0001. So now we have the LLM response in text sentence, like has shown here, and the human annotated response as in yes or no format. So here S means the variable information is available in the publication, and no means the variable information is not available in the publication. So to compare any of the 2 outputs, so they need to be in the same format. So for example, here we have the LLM response in textual format or textual sentence format, and the human response in the categorical format like yes or no. So then to compare these 2 outputs, we decided to convert the LLM response into categorical format like yes or no using the LLM again. For that, we use the prompt template as shown here. So for every given question answer pair, so LLM role is to convert that answer to a binary response like yes or no. So after this process, we have all the responses of human and LLM in same format like yes or no format. So now we have calculated inter-annotator agreement between the human and LLM responses. So here the table shows the inter-annotator agreement calculated using scikit-learn. So here the link is provided between different combinations of the annotator and LLM responses. So here the inter-annotator agreement score of 1 means the maximum agreement and -1 means there is no agreement. So here the first row shows the combination of human annotators, so which has the inter-annotator agreement score of 0.54. So that means it's a moderate agreement. And the last two rows shows the combinations of human and LLM response, where the IAA scores are 0.16 and 0.12 respectively, which indicates a slight agreement. So basically the IAA of human annotator combination is more compared to the IAA scores for the combinations of human and LLM responses. So why? This is because the human annotators had access to wider set of information, like the code, data, figures, and tables. So while we are doing this, we extracted some information from codes and data and so on. So in case of LLM, it's completely dependent on the textual information provided. So this is the main difference, or maybe this is the main reason for the differences between the IAS scores. Now, in conclusion, we have shared the LLM-assisted methodology for automatically extracting the information from biodiversity literature, so without any human input. And we have also shared the respective prompts used in our methodology. So finally, we compared the different combinations of outputs using inter-annotator agreement. In future work, one important aspect is we need to evaluate the responses generated by LLM, so which is very important to trust the results of our work. And the next thing is where we need to find a methodology where we can use the figures, tables, code, and data by employing different pipelines or maybe using one synchronized multimodality model. And another aspect is like ensemble models, to use multiple models and get the output via voting to get a more trustworthy answer. And the next one is like we obviously plan to report the compute resources and its environmental footprint. And finally, we wanted to scale this up by using more publications. So that is it. If you are interested to use our code or get in touch with us, please scan the QR codes. So thanks for your attention, and I am open for the questions.
Awesome, thank you so much. And we do have the presenter online, so if there are any questions in the audience, please feel free to come up and ask those. And once again, I will be monitoring the chat for any questions.
Hi, we also conduct a work based on RAG technology, and there is an issue that there is a result, I call it chimera answer, like the LN give our results. There's a part from A literature and another from B, because there are maybe different thoughts in our literature or our docs, the LN it is. So do you have any suggestion for us to avoid this issue or to deal with it? Thank you.
Hi.
We can hear you.
So, super. So, as I understood, you have two answers from different literature, and you wanted to combine them using LLM, right?
Can you repeat what you said? I think you cut out for a second.
So as I understood correctly, the speaker had two answers from different literatures. So then they wanted to combine them using LLM. So did I get the question right?
Repeat my. Okay. We have encountered a problem is that when we use RAG technology, the chatbot the chatbot reads the different literature, but there are different sounds in this literature. So the chatbot gave us the result that I call chimera answer, that apart from A and another part from B, but they are conflicts with each other. So do you have any suggestion for me or for us to avoid this circumstance or to deal with it?
So, so basically, that means you have different answers in different parts of the publication. So where you can take multiple answers, like retrieved chunks, and then use get more chunks out of the RAG and then provide this as an input to the LLM. So this is one possible way. And the second possible way is there is a new methodology from Microsoft. It's a graph RAG.
Right.
So basically this graph RAG will create a knowledge graph in between and then answer based on this knowledge graph. So I think GraphRag will definitely combine all the information available in different parts of the publication. So maybe you could try GraphRag, and maybe also the first suggestion, like you can get the multiple chunks and then provide that hash to the LLM manually, not manually, but using programmatically, you can do that.
Okay.
Thank you. And if you need more information, you can definitely get in touch with me.
Okay.
Awesome. Okay, thank you so much. Let's give one more hand for the presenter. And our next presenter is also the co-organizer of this session. Rukaya will be presenting on the ChatIPT assistant for easy biodiversity data publishing and will be available for questions afterwards also.
Hi everybody, I'm Rukaya. I work for GBIF Norway and I'm going to talk to you about ChatIPT. So this chatbot is for helping students and researchers who are new to data publication get their data published really easily. It cleans structures and standardizes spreadsheets, makes basic metadata, basically guides the user through the data publication process, and it actually handles the data publication to gbif.org itself as well. I'm going to show you an online demonstration, and I'll be using a student's data set. I've changed the values in the data, but it's basically the same kind of structure. So we have like one row per species, and then 4 different localities where we have observations. So those are in the last 4 columns. And we also have a second sheet, which has some GPS data and dates, collection dates for that data. So this is the front page, and you can see there is a little welcome box which pops up. It's got a description of what the chatbot is and why we need it and so on. I'm going to close that, and you will see the first thing that it's asking for is a user's data file, which it wants us to drag and drop over here. I'm just using the data file that we were looking at earlier. You can see that the 2 different sheets have been loaded into the right-hand panel. and it's possible to scroll through the data and sort it and organize it and so on. And this right-hand panel is a live update of gets updated as the chatbot works through the data. So the first thing that it's doing is checking to make sure that this is biodiversity data that we want published on GBIF, and it's generating a little bit of metadata for us. So I'm going to say this title, Marine Species Assemblage Data from Southern Africa Bays, and the description sound fine. And you'll see that it saves the title and description at the top of the page over here. It's also looked through the data, and it's made some notes about the structure of the two different sheets, which it'll use in future tasks. It's also noticed that this is the kind of data where there are sometimes images. So it's asking if we have any images that we'd like to add to the data set, and explaining the process of how you would do that. So I'm just going to say I don't have images for this data set. Okay, and now it's moving on and loading the next task. Now the next task is where it actually starts doing some formatting and restructuring of the data. You can see, in fact, that the two tables have disappeared. We now have one table, and it's made some code which is run to create that one table. So it has incorporated the latitude and longitude, and it's created an occurrence ID. Oh, it's going faster than I can talk. So it's also done some validation of the Darwin core terms that are in here. And now it's going through and making a final pass of the data. So if we have a look and see what we've got here, this is all looking quite good now, I think. So you can see it's been running more tasks and doing a little bit more tidying up. Here it's telling us what it's done so far, and it's asking if everything is looking okay and fine. So I'm just going to say let's go on. And you'll see here that a little message has popped up at the bottom saying your dataset has now been published. And there are two links, one to view the datasets on GBIF and one to download the Darwin Core archive file. And it's just letting the user know that it's in the future going to be possible to chat with the bot to edit your data as well. So let's take a look at what it's created on GBIF. This is the GBIF UAT website, obviously, so we're not running this on production. And you'll see that the title, which we came up with, is over here, and the description as well. And here are our occurrences, which are all populated through here. So we've gone very, very quickly and simply and easily from an unstructured spreadsheet through to published data set with as little fuss and hassle as possible. So what we just saw in the demonstration video in the previous slide is working behind the scenes with the OpenAI GPT-4o API. So we're passing it a series of prompts. There's like a generic prompt template, and we insert sort of specific task descriptions into that template, and we send each one through. So, for example, this is the generic prompt, and you'll see at the top it says something about using the user's language, and then it has things like conversational rules explaining that users are biologists and ecologists with no idea of what Darwin core is and so on, so you have to explain things nicely and do as much as you can to make the data publication process easy. And this is the first task that we send it, for example. So this is where we check to see whether data is actually suitable for publishing on GBIF. And we explain what GBIF is and the different types of data and so on. And we send that off wrapped inside the generic prompt template I showed you just now. So as well as sending these prompts through, we also give it access. We tell it that it's able to run a number of different tools. And the most important one is that we tell it can run Python code on the spreadsheet that the user has uploaded. And what happens is it generates the Python code, and we run the Python code on the server and send the results back. So other tools that it has is it has access to like a basic Darwin core field validator. It has access to a function which creates Darwin core archives, and it has access to a function which registers and publishes the Darwin core archive with GBIF. Right, so problems and future development. The main thing, the really tricky thing with this is that users, when they store data in spreadsheets, they store things in incredibly different ways and sometimes quite illogical ways. And obviously we have years and years of experience of knowing how to deal with those and how to sort of split things up and what things look like, but ChatGPT doesn't. So it's important to get the prompt sort of open and flexible enough for it to have the creativity to sort of deal with things on the fly and things that are impossible to predict or expect. But we also need to give it direction so that it actually knows what it's supposed to be doing. So getting that balance right is quite difficult. And the only thing that's going to make it better is testing. Lots and lots and lots of people trying it out and seeing how well it does with different types of data. Okay, I think that making edit access to already published data sets, that's something that's going to be pretty easy to do. So that's next on my list of things to do, as well as making a user dashboard to show all of the data sets which have been already published. Yeah, we're currently publishing using the GBIF Norway publishing institution, which is fine for people in Norway. But I feel like there is possibility for this to be expanded and opened up to more countries, because not every GBIF node has the resources to deal on a one-to-one basis with students and researchers who need one-on-one help to publish their data. So I feel like there's a lot of data which is probably just getting lost by the wayside, which we could be publishing. Additionally, I'm not fluent in another language, so I don't know how well it does. It's ChatGPT, so however well ChatGPT works in another language, that's how well it will work on this chatbot. The prompts are also very much targeted towards occurrence data at the moment, so that should be expanded. And of course, it would be nice to experiment a bit with open source models. And this is quite a cool, I think we do need some kind of login and basic user validation system. I mean, it needs to have safety rails in to check and make sure that the data published is actually biodiversity data, and that is coming from somebody who is at an institution where at an educational research institution. And I think that probably we would need some manual validation for that, but additionally, we could use OrcID logins. So people could log in with their OrcIDs, and that the information on their OrcID profiles could give the chatbot additional context, which could help it with the data publication process. For a start, it could generate metadata much more easily, getting the institution name and address and so on for the metadata, so the user doesn't have to manually specify that. And that's the end of my presentation. Thank you for listening.
Okay, so we do have one question and answer that I would like to share from the chat. So Alan Stenhouse asked, were all the modifications accurate? And Rukaya responded, the modifications for the data set to get it published, yes. Or at least it's what I thought would have done, sorry, or at least it's what I would have done to get it published ready. So we don't have time for other questions, so please reach out to Rukaya directly if you have any questions. And we are going to move on to our final, to our final presenter of the day. And that is Arianna Salili-James, and she'll be talking about unscrambling the eggs, automated data extraction from structured cards.
Hello, okay, can you guys hear me? Okay, so I know it's 5 p.m. and you might not want to listen to another LLM talk. So I'm very sorry, but this will be an LLM talk. There is at least a cute picture of a bird on the last slide, so stay awake and you can see a cute bird. And yeah, thank you for being here. So the title of my talk is Unscrambling the Eggs, Automated Data Extraction from Structured Record Cards. So spoiler alert, it's only half egg related, but I really wanted a pun in my title, so there we go. So the talk contents. So I'm going to be mainly talking about the journey of this project. So the journey didn't actually begin with LLMs. It began with computer vision related things that were slightly different. But I'm going to talk about that journey, talk about how it started with the eggs and how it's developed over the last year. So mentioning a variety of different museum related projects. So what's our general goal? So we are working with structured cards here, so we're not looking at necessarily really complicated text descriptions. We're looking only on structured related cards. So this could be index cards, for example. This can be specimen labels. This can be collector cards and things like that. Things that have a structure. So that's either a structure given by boxes. So maybe like these examples there are different boxes and there are values inside the boxes. Or there could be no boxes at all, but you have category titles. Or it could be something like a label where there's no boxes or category titles, but it's fairly obvious that there are only a certain amount of categories in there, like a registration number, a locality, a date. So with the question is, how can we create a tool that curators can use or other researchers can use where they just submit a folder of images and then you get a CSV in the end with everything categorized with the information in there. So it's not just a transcription question, it's a transcription and categorization question here. So starting with the NHM trig eggs. So firstly, who knows about NHM trig? Any hands up? Okay, a couple people, NHM people, put your hands down. I know you guys know. Okay, so NHM, when you think of NHM, we think of NHM London. So in London, technically, there is two things. Yes, we've got NHM South Kensington with the main museum. There's also storage facilities elsewhere in Wandsworth, but we also have NHM Tring. Now, I love birds, so I am incredibly biased, but I think NHM Tring is better than NHM London because it's all bird focused and it's absolutely amazing. And for example, there's a section with about 16 kiwi birds in one display. At NHM South Ken, we have one kiwi bird. So it just shows how cool it is. So if you've not been, I would recommend going. Anyways, so this project was in collaboration with the NHM Tring folks there, primarily Douglas Russell, who is in charge of eggs and nests. So it started off with Douglas giving us a bunch of egg index cards. Each egg comes with an egg index card. Not entirely correct. Sometimes there are multiple eggs to one index card, but let's not get into that. And when we started with this project, everything looked very nice in these boxes. So we had a box with the registration number, with the species, locality, collector, etc., etc. And this was before LLMs were very popular to use and when LLMs were a bit more expensive as well. So we thought, since this has such a nice structure, why don't we just use a more vision approach? We know where all the lines are. So we started to use Google Vision, and that's the route we went with. So this was the OG method. So the OG method, we put everything into Google Vision to get all the transcriptions out. If you've not used Google Vision before, Google Vision also gives you coordinates for bounding boxes. And this is what was really useful for us. So we knew where each text box was. So then we used that to work out what a category box was. So I used the same colors here, which is very silly of me, but these are what Google Vision gives, so the text boxes. But then we can use that to work out what a category box is. And that was fairly easy for us because we knew that the species was always at the top. We knew that at the second section, it'll be locality and collector. It was always the same structure. So it was very, very easy to do it this way. So all we had to do was associate a text box to a category box. And then you can then easily categorize everything, do some basic text processing. By that, we can mean maybe changing things from capital letters, removing punctuation, but also more in-depth things like making sure species are linked to certain taxonomy names, so linking it to Howard and Moore taxonomies and things like that. And then that can then get uploaded into a museum database. So using this, we went through about 20 drawers so far, various sizes. So some of them have more than 1,000 images of egg cards, some are only about 500, but overall there were a lot. So a lot of these were put into a lot of drawers. We did some accuracy testing for this as well, and the accuracies were really, really good. So yeah, almost 100% on everything here. Now note here that by this kind of accuracy, at least in this table, this was more of a binary classification of whether this was right or wrong. So we're not doing Levenstein distances or anything here. We just we went through it manually and checked whether it gave out the right information. So if something was written slightly differently to the box, maybe there was a hyphen that was missing, or there was a lowercase bit, or instead of LK for lake, we wrote LAKE or something like that. That was classed as correct. So this is very basic accuracy things here. And from these very basic tests, registration number was the lowest accuracy. And you might be wondering why this is, but for us, we realized it's because the registration numbers half the time were rotated, so they were vertical. And when they were vertical, Google Vision was very confused, thinking, which way around is this? How should I rotate it? So it starts to rotate things incorrectly. And sixes became nines and nines became sixes, and that kind of ruined everything for us. But 92% isn't too terrible, so I shouldn't complain too much. There were some other difficulties as well, so different symbols being used. So there were Greek letters being used, for example, to represent things. Yeah, the 6 and 9s were a very annoying thing, the rotated text. And there's also lots of varied cards. So at the beginning, we had a very simple structure, but soon we realized that that is not the case. There's a lot of index cards ranging from 1830, I think was the oldest one, and they're still collecting it. So it's a long time period. And we don't always have the same category titles on there either. So what can we do about this? So are LLMs the way forward, which is what we asked ourselves. Okay, I know you've heard a lot of LLM talks. I'm very sorry, guys. I won't talk too much about this, I promise. I'll go straight to the examples. But briefly, yes, LLMs were great for us because we don't need to rely on things like boxes. We don't need to rely on things like category titles. And we can start applying them to larger, more diverse data sets, not just looking at the egg cards. So we expanded this project with help from lots of curators at the museum. So expanded it to other bird cards, like bird skin labels. Bird skins are essentially the birds you see in drawers. You take them out, and there's loads of labels associated with them. And we focus on labels from a certain collector. So Hume is the name of the collector. And we also worked with other organizations. So BTO, the British Trust for Ornithology, please don't correct me on that. And we worked on some cards from there. So the nest cards were from there, which were much more complicated, which I'll get to. And there was also some tests that we did on registers. And I know I said we were doing structured cards. Registers are still structured, so they might not be cards, but they're fairly structured, so you can do similar things. So the rough method here, so there's two things. Either we know the data set, so we know the categories, and then we put it in the LLM, or we don't know the data set and the categories. So what if we just put a bunch of images from different things, but we want it to still be grouped together? We want the same categories to be taken out for the same cards, but not necessarily the same categories across everything you're putting in there. So if you're doing it more generally, then the first thing you need to do is classify the type of image it is. Is it an egg card? Is it an S card? What is it? And then when you do that, you can get the category titles out of there, feed it into your LLM, extract whatever you want, the CSV, JSONs, basic data processing, and then upload them onto the museum database. So that's just the general thing we're doing here. So it can be applied to many types of data, and it doesn't require that much training. We don't need to think about boxes and things, so it's much easier. Disadvantages, they are not cheap. LLMs aren't cheap to work with. They might not be expensive to use once you've figured out what prompts to use, but testing it is not always easy. If you want to be doing things like reproducibility tests, you're going to need lots of testing, and that's not always cheap. So you end up relying on interfaces sometimes, which have a cheaper price plan, but then there are issues with that as well. But again, you guys have heard a lot about LLMs, so you don't need me talking about that. Okay, one last thing, reproducibility was the other issue that you get with LLMs. So we did do some further testing with this. So for example, I'm sure some of you have tried things like the temperature variability. If you don't know, temperature controls creativity roughly. And if you lower that temperature, you get less creativity, but maybe less made up answers. So that's something that we played around with as well. And that really helped us. So once we did actually do some reproducibility testing here, and we used the same prompt on the same images with very basic prompts as well. And then we tested it against each other, and we computed Levenshtein distances, and we also computed fuzzy matches as well. And we found that the reproducibility with the lower temperature was really good. I'm talking between, okay, not really good, but between 80 and 100% for most categories. The lowest category, as always, was the registration numbers. And that's because, again, some of them were vertical, and it does not like rotated things. So there's still some problems. So just quickly going through the examples. Oh my God, I have 2 minutes left. So this was one example with some fossil mammal cards that we had. Fairly good results here. So we had, again, we did a binary classification here. So looking at perfect, first we just looked at perfect results. So almost, so that meant just identical. Was this identical to what was written on the card? But we also did something called almost accuracy, which was things like slightly differently written, differently capitalized letters, different punctuation. And we were getting very, very good results with these. With the Hume labels, we decided to not only test what we've been testing so far, but an additional test of what should we be putting into the algorithm? Should we be putting in absolutely perfect high quality images, or can we get away with just using our mobile phone to digitize these things? How well does that do? And we found that we were actually getting really good results. We had a comparison with things digitized using scanners, things digitized using high quality cameras, and also things digitized with a very old, I think this was a very old iPhone. And we found out that we got the same results. Using an iPhone was so much quicker, and the results were the same. So that was fairly nice. And lastly was the BTO Nest cards that I wanted to mention. These are much more complicated because now it's not just text. You've got things like tick boxes giving out information. You've also got boxes that are separated with drawn out lines. And honestly, I had zero hope that it would work, but it is working, which is absolutely remarkable. Next steps for us, so we're creating more accuracy metrics with the experts doing more Levenshtein distances here. So we're doing comparing with the manual things like all my peers before me have talked about in this last session. And also we're going to talk more about registers as well. So work with registers, get the information out that's useful for the curators here. And yeah, create our own LLM-based interface as well that could be used throughout the museum. So our aim here is, one, to help curators get information out from all their cards. It will help them do lots of curation work, but also to learn more about our data sets. So I called this title Unscrambling the Eggs because we want to learn about all the eggs. People use birds to talk about climate change analysis. How have birds changed over time? We've got a 200-year-old collection here. If we can get all this data digitized, extract that information, then we can analyze these cards. And that leaves 10 seconds for questions. Thank you, guys.
So we do actually have one question online, and that is, it's from Pietro. Did you have habitat data and or interactions with other species, e.g. some egg collector would note the feathers of the other species that were used for the specimen's nest?
That's an excellent question. So we do have that data, but we haven't used it yet. But the idea is that hopefully we will be linking those at some point, but just not at the moment is the answer. But we are thinking about it, so thank you.
Yeah, and we can take, you're welcome to come down, but we have our normal like 15-ish minutes for discussion or any additional questions if you would like to ask those. Before we do that, however, I would just like to take a moment and reflect on how much AI has grown over the last year, and even talks that we were having last year are almost out of date compared to what we're doing this year. So this is an amazing field that is rapidly growing, and I just want to make sure to say that I'm very impressed by what everybody has presented in person and also online, because these steps get us closer to being able to use AI at scale for biodiversity across multiple disciplines. So I just want to make sure that all of you know how amazing your work is, how hard it is what you're doing, and just how impressed I am and how much progress we've made even since the talks last year. So yeah, with that being said, I'll stop being mushy. And if anybody has discussion points or additional questions, please feel free to come up and ask those or put them in the chat. Also, I know it's super late, so if everything has already been said, that is totally fine. I'll give it a couple more seconds to see if anybody asks anything on the chat or if anybody wants to come up and talk about anything. Okay, yeah.
These mics are so tall. Hello. I would just want to, it's just a comment really, that so many of us were talking about LLMs, and it just emphasizes the fact that we were making in the earlier session, which was that we really need to come together more and talk about these things more and create a group repo or a group Slack or something, because we're all doing very similar things. So yes, let's keep in touch after this, please, guys.
I know nobody wants to add one more thing to their plate, but a really awesome idea, since we are at a TADWIC conference, is people could start a working group or an interest group to see if there is a way to standardize these prompts or get together and do things. So infrastructure. And please feel free to reach out to xcom@tadwig.com if anybody wants to start this group.
This is just a plug because this is such a hot issue. The Fantastic Futures, which is the AI conference, international AI conference for LAM, so Libraries, Archives and Museums, is being held in Canberra in October. So you can attend virtually, but it's because it's Libraries, Archives and Museum, it'll be put towards the kind of perhaps historical section, but a few of us from this community are actually going either virtually or in person. Easier for me because I'm like an hour's flight away.
But it balances out because it's so hard for you to get anywhere else from Australia.
It's on the 17th and 18th of October. I can pop it in the chat or something.
The question was, when does registration open for this? And okay, registration is open, and Nicole is going to put more information about attending this conference in the chat, and I will copy that over to Oxford Abstracts within the next 24 hours so people can get information that are in the room. But if you're on Zoom, feel free to take it right now. Okay, cool. Well, that was enough silence. So thank you so much again on behalf of Rukaya and I for attending this. We really appreciate it. And I'm serious, like definitely look into starting a task group or an interest group regarding like anything related to AI. So thank you again, everybody. Give all of yourselves and everybody who presented one more big hand. And And it is 5:14. So if you are going to bingo tonight, please remember that the buses will start leaving at 6 p.m. and we are meeting at the conference center. Other than that, I hope you guys have a great day and congratulations on making it through our AI marathon.
So they didn't see anything that was going to. That's great. I kind of assumed that.
There's nothing too complicated about it.
Oh yeah, they've got tons of insights.
Go through a batch change off of standards.